Hello everyone. In this video, we will explore how a linear transformation of the force of mortality will affect the survival probabilities. Suppose the force of mortality of a person at age X is mu X plus S for a period of T years, and the corresponding survival probability is TPX. If another person also at age X has a modified force of mortality, which is a constant multiple K times the original force of mortality. Then, by definition, the modified survival probability, the new TPX, this is equals to the exponent of the negative of the integral of the new force of mortality. Upon simplification, we get the relationship. The modified survival probability equals the original survival probability raised to the power K. If the modified force of mortality is K times the original force of mortality. Another modification. If the modified force of mortality equals the original force of mortality plus a constant C, then the modified survival probability equals the original survival probability times e to the power minus c times t. Combine these two modifications, where the modified force of mortality equals a constant k times the original force of mortality plus another constant c, then the modified survival probability equals to the original survival probability raised to the power k times e to the power minus c times t. This is the key formulas in this video. Let's apply this with an example. Suppose the force of mortality of smoker at age X is mu X plus T, where T is between 0 and 1. And given that Qx equals 0.08 for smokers. Suppose the force of mortality of non-smokers is mu X plus T with superscript NS, which is equals to 0.5 times the force of mortality of smokers minus 0.01. We are asked to calculate Qx for non-smoker. All right, let's take a look at the solution. We have the key formulas here. All right, so we need to get Px. We already have Qx equals 0.08, so Px is 0.92. And from that, we can already substitute all the quantities in the new formula to obtain the modified survival probability for non-smoker. And then we get the Px. Take 1 minus Px, we get the Qx. So here, Px is 0.92, where T equals 1. And then K is 0.5, and C is negative 0.01. If you cannot memorize the formula, then we can evaluate this from the definition. Okay, Px is e to the power of a negative of the integral of the force of mortality. To get the Px for non-smoker, okay, by definition, we have this expression. And then upon calculation, we get Px raised to the power 0.5 and e to the power 0.01. All right, so to get Qx for non-smoker, which is equals to 1 minus Px for non-smoker, and then substitute Px equals 0.92 into this expression, then we get the desired probability, 0.0312. This is the value of Qx for non-smoker. All right, the next example. Given that P45 is 0.92 for a standard insured with force of mortality mu 45 plus T. For a preferred insured, the force of mortality is mu minus D. The force of mortality of a standard insured minus a constant D. Suppose the probability that a person aged 45 will die within 1 year is 35% lower for a preferred insured than for a standard insured. Determine the value of D. All right, so we have the key formula again. For preferred insured, I use an asterisk. So we have P45 for the preferred insured, which is equals to P45 times e to the power minus D times 1. So here we have TPX equals P45, and then K is 1. The constant multiple here is 1. And then C here is minus D. So we have the minus D here. And then the value for T is 1. All right, so the preferred survival probability P45 is 0.92 times e to the power D. And then the mortality probability Q45. Q45 is 0.08. And the preferred insured, the Q45 is 35% lower for a preferred insured than for a standard insured. So Q45 for a preferred insured equals 1 minus 0.35 times Q45, and we get 0.052. All right, equate the two expressions for P45 for preferred insured. So we get P45 here equals 0.948, which equals 0.92 e to the power D, and then we can solve for the value for D. D is 0.03. All right, that's it for today's video. In the next video, we will talk about the expected value of Tx. Thank you and see you in the next video.